Now, if you didn't see my previous video, Trip to Mars, the setup, you better go back and check that out, or this isn't going to make any sense. Now, if you watched that video, you watched it, we took all of these words and interpreted as this. Right down here, we let X be the number of video games, Y be the number of movies, and we took all these conditions up here and turned them into these inequalities. And our goal is to maximize 4x plus 2y. We also had the condition that x and y have to be non-negative. Can't have a negative number of video games or negative number of movies. And what we did in the setup was we graphed all of these inequalities over here, and we saw that the points that satisfy all three of these conditions are the ones that are on the graphs of all three of these inequalities. And that came out to be this region right here. And our goal is still to maximize 4x plus 2y. So we want to find the point xy inside this region or on the boundary that makes 4x plus 2y as high as possible. Now we'll start looking for that point just by playing around a little bit. I'm just going to pick a point right in the middle there. I'm going to pick 50-50 and see what happens. Now at the point 50-50 we get 4x plus 2y equals 300. Now of course we know we can do better than this, right? Because we can just move a little bit to the right here. We can just increase x a tiny bit. Check this out. If I just increase x a little bit, I go over to 60-50, then I get 4x plus 2y is 340. So clearly actually I can move x over a little bit more. I can increase this a little bit, increase x a little bit more, move a little more to the right. I can go higher and higher and higher all the way out until I hit the boundary. So clearly I don't want to be anywhere in the middle, because if I'm anywhere in the middle, I can always increase 4x plus 2y by moving a little over to the right. So I don't want to pick any point in the interior. No point in the interior is going to maximize 4x plus 2y, because I can always do better just moving a little bit farther out. So I definitely want to be out here on the boundary somewhere. But where? Where in the boundary do we want to be? Hey, wait a second. Check this out. This 4x plus 2y equals 300. We can graph that. That's just the equation of a line. Let's check this out. Like this line, we know it goes through 50-50 because we got the point right there. That's how we found this in the first place. This line also has slope -2. If I solve for y here, subtract 4x from both sides, and then divide by 2, I'll have y equals 150 minus 2x. Minus 2x, that tells me that the line has slope -2. And I happen to have a line with slope -2 right here. So there it is. This is the line through 50-50 with slope -2. This is the graph of 4x plus 2y equals 300. Now for this one, 4x plus 2y equals 340, the slope is still the same. I haven't changed the coefficients of x or y. I've just changed this out here. All the lines that are 4x plus 2y equals something, those all have slope -2. You can see that by just solving for y. Subtract the 4x, you get 2y equals something minus 4x. Divide by 2. You get y equals minus 2x plus something divided by 2. Minus 2x, the slope is still -2. So all the lines that look 4x plus 2y equals something, they're all parallel. And check this out. This one's just what we get when we slide this line out just a little bit. That brings us to the line 4x plus 2y equals 340. So as we're sliding the line outward, we're increasing this number over here. That's all we're doing. So all these lines, 4x plus 2y equals something. As the something gets higher and higher and higher, that's the same thing as moving this line out farther and farther. So what we're looking for here is the line. I want this line to go out as far as it possibly can, but it still has to intersect something in the blue region. I can't put the line out here because it doesn't hit any point in the blue region. This orange line won't ever hit any of those points. So I still have to make sure I have to hit something in the blue region. Now if I go here, through a boundary point, I'm through a boundary point but not through a corner, I still clearly can move farther to the right. Because if I'm going through the boundary but not through a corner, then I'm going to end up going on the interior of this blue region again. Clearly I can move this blue line out farther. So where I know I'm going to end up, where I can maximize this 4x plus 2y, is when I hit a corner. It's going to be one of the corners. Now we don't know which corner. We can tell by looking at this graph it sure looks like it's going to be that corner. But without drawing lines we wouldn't know for sure, but we know it's going to be a corner. The farthest out line is going to be at a corner, because if I'm going to go through the interior I can definitely move farther out. If I'm going through a boundary but not through a corner, then I'm still going to be able to move farther out. So I know that the winning line is going to go through one of the corners. So now I know all I have to do is test each of these corners and see which one gives me the highest value of 4x plus 2y. And we know where all these corners come from. They come from the boundary lines here. So for example, this one down here is where the red line hits the x-axis. The red line comes from 8x plus 3y equals 1200. So when y is 0, x is 150. So this corner point is 150, 0. And then this corner point right here comes from the intersection of the yellow and the red line. The yellow is x plus y is 200. I can find the intersection of that with the red line with a little substitution. We can solve this for x, 200 minus y. Substitute in down there. We get 8 times 200 minus y plus 3y equals 1200. And we're just solving for this intersection point right here. Over here we'll have minus 8y plus 3y. That gives me a minus 5y. This gives me 1600. Subtract that from the 1200 over there. We get minus 400, so y is 80. Then I can use this equation up here and I get x is 120. So this is how we can find all of our corner points. So we actually kind of didn't even have to draw the graph. The graph gave us good intuition, but now that we know that all we have to do is test the corners here, we can solve these systems of equations to figure out what all these corners are. Here's the next corner, is the corner where the yellow intersects the green. Yikes. So what I'll do first with the green, multiply through by 5 because those decimals kind of freak me out, and I'll get x plus 4y equals 650. Now if I take this and subtract x plus y equals 200, I'll get 3y equals 100 equals 450, so that'll tell me that y is 150. So x will have to be 50 because x plus y equals 200 on the yellow line. So that's this corner up here. And then last is that corner right there where this right here hits the y-axis. That means x equals 0. Divide by 4. Y is 162.5. So these are the corners we have to worry about. Now, of course, for this problem, we know we're going to be at one of these corners out here. We got this line slope -2. Let's go ahead and test each one. For this corner, we put in 150, 0. 4x plus 2y comes out to be 600. For this corner, put in 120 and 80 there. 4 times 120 is 480. 2 times 80 is 160. That gives us a total of 640. This corner up here, put that in. 4 times 50 is 200. 2 times 150 is 300. That gives us a total of 500. And then for this one, I'm just going to be multiplying 2 times 162.5. That's going to be tiny compared to these others. So this point comes out with the highest value. This one is the winner, as our graph suggested it would be. And we see that we need 120 video games and 80 movies. So, there's more. I want to make sure we really understand this. What we're going to do here is we're going to change the problem just a little bit. Just a little bit to see that it's not always this corner that's the winner. Imagine that instead of these 4-hour video games, I have video games that are going to take 6 hours. These are really good video games, much better video games than the other ones were. Now here we were trying to maximize 6x plus 2y. And the same thing, we graph all this stuff, we got the allowable region here. Everything holds exactly the same, except here, instead of lines of slope -2, we're looking at lines of slope -3. Like this one, for example. And the reason for that is what we're trying to maximize here is 6x plus 2y. So we're going to have equations like 6x plus 2y equals something. I'm going to use k. Now again, if we solve for y here, we get 2y equals minus 6x plus k. Divide through by 2, we get y equals -3x plus k. And that's why we're looking at lines with slope -3. Whichever one of these comes out to be the winner, we're going to have a line with slope -3. We want the one that's going to be farthest out, just like before. And it looks like it's going to be this point this time, this corner instead of this one. But once again, we test. It's clear we don't really have to test these two. These two aren't going to win. I mean, if you want to go ahead and look at that one, put in 50, you get 300. Put in 150 for y, you get another 300. That comes out to be 600. But look what happens when we try this point here. 6 times 120 gives us 720. We're already above that. 2 times 80 gives us another 160. So 160 and the 720 that we already had gives us 880 for that point. But then when we put this point in, the 150, 0, 6 times 150, that gives us 900. So 6x plus 2y is 900 for that point out there. This point out here is the winner now. So for this setup, when the video games take 6 hours, when we have really good video games, we want to go ahead and get 150 of the video games, and we're not going to be able to get any movies at all because we're restricted. And we can see which restriction restricts us right here. Which one ties us up is this red line. This red line, we're at the boundary of the red line, so it's the money restriction that prevents us from being able to get more movies or more video games. So let's take a look at one more setup. Imagine the video games are really bad. These are just 1 hour video games. Very, very boring video games. Now here we're trying to maximize x plus 2y, and we think of it the same way. Each point we pick in here, we'll have x plus 2y equals something. We'll call that k, and again we solve for y. And this time we see that all these lines have slope 1/2. So now we're looking at lines more like this. And of course, I happen to have a line with slope negative 1/2 right here. And we want it to go as far out as we can, as far out as we can, as far out as we can. Now this time it looks like it's this corner up here that's going to be the one that provides the maximum value of x plus 2y. And let's go ahead and check that out. So we'll start off with this point down here. If we put in 150, 0 in there, we'll just get 150. Now if we put in 120 and 80, we'll get 120 plus 2 times 80. 2 times 80 is 160, and the 120 gives us 280. Now 50, 150, put in 50 here, I'll get 50 plus 300. That gives us 350. And then lastly, I'll put in this one, this 162.5 for y. That'll give me a 325 right there. So this point does indeed, this is the corner that gives us the largest possible value of x plus 2y. So in this scenario with the bad video games, well, I want to buy 50 video games and get 150 movies, but I'm only going to be able to waste 350 hours doing this. This is a lot better because I get to waste 900 hours. I need to find myself some really good video games. Got any suggestions?